G'day guys, we've got a conservation momentum question here for you today where we've got three carts, C1, C2 and C3, where C1 has half the mass of C2 and C3 has an unknown mass which we're going to call X. The question is divided into two parts. Now let's start with part A. Initially C2 is at rest and C1, which is travelling at 4 meters per second, strikes C2 and the two carts join together and continue to move. So what we've got to do is, showing our working, we've got to determine the magnitude of the velocity of C1 and C2 after they have joined together. Okay, so this sort of question, let's start with writing it down. Question part A. We're basically, conservation momentum says that for perfectly elastic collisions like the ones we're talking about here, no momentum will be lost in the collision. So the total momentum before the collision will equal the total momentum after the collision. So what we're going to say is momentum 1 is equal to momentum 2. Now, so for this case, we've got momentum is equal to the mass times the velocity. So I'm going to say mass 1 times the velocity 1 has to equal the mass 2 times the velocity 2. Now, we are well aware of what the initial momentum is of the pre-crash situation, because all of the momentum is contained within C1. Why? Because C2 has no velocity, so there is no momentum here. So C1, the mass of it is m divided by 2. And we're multiplying that by its velocity, which is 4 meters a second. Now that has to be equal to the mass after the collision, which is equal to C1 and C2 added together. So we've got m on 2 plus m. So that's going to be 1.5 m, or 3m on 2, times by the velocity after the collision, which we're trying to find out. Cool. So what we're going to do is we're just going to clean this equation up a little bit. Let's just move it up here for space. So what we're going to do is m over 2 times 4 is just 2m, is equal to 3m divided by 2 times v2. Cool. So if I move the 2 over to the other side, I'm going to have 4m. And if I divide it by 3m, I'm going to be left with v2 equals 4m divided by 3m. Now, obviously, the m's, the mass, because it's, in this case, it's a relatively arbitrary unit, will cancel, and we'll be left with v2 is equal to 4 divided by 3 meters per second. Cool. So let's get straight on to part B, guys. Okay, so let's just have a look at what our situation is for part B. C1 is now moving with a velocity of 10 meters a second to the right. C3 travels towards C1 at a velocity of 16 meters to the left. The carts hit and C3 rebounds with a new velocity of 24 and C1 remains stationary. So again, guys, what we're going to do is the momentum prior to the collision is going to have to equal the momentum after the collision. So what we're going to do is, now both C1 and C3 have a momentum. So what we're going to do is we're going to calculate the total momentum here. So we have C1, so the momentum, let's just go the momentum of C1, now this is all prior to the collision, is equal to mass times velocity, which is equal to m divided by 2 times 10. Cool. However, Yeah, well, let's just do it like this. And then what we're going to have is momentum of C3 is going to be equal to the mass, which we don't know, times the velocity, which is in the opposite direction to C1. So because this is going to be a vector quantity, we're going to call this negative 16 meters a second. Cool. So what we have is our initial momentum if we were to add these together. So let's just call it P1. It's going to be equal to 5m minus 16x. Cool. And what we have next is we're going to have our P2, or our final momentum. So what we have is C1 remains stationary, so the mass of this is not important, and the velocity of this is not important because there is no momentum. It's just the momentum is calculated from C3. So our P2 is going to be equal to mv, which is mass is x, times 24. And that's in the same direction as C1, so we're going to keep this positive. So this is going to be equal to 24x. Cool, so what we're having to do in the second part is we're trying to find the mass of C3 in terms of C1. So basically we're having to solve for x in terms of m. So we know that P1, this is our law of conservation of momentum, has to equal P2, or rho 1 has to equal rho 2. Let's go for space, I'm just going to move this up. And as a result, P1 is 5m take 16x, has to be equal to 24x. Cool. So what we're going to do is I'm going to take the 16x over to the side. Cool. So I've got 5m equals 40x. Okay, so now what I can do is I can work at my mass of C3, which is x, is going to be equal to 5m on 40, which is obviously equal to m over 8. So the question is asking us, determine the mass of C3 in terms of C1. We know that C1 is equal to m over 2, C3 is m over 8, so this is a quarter of the mass of C1. So all I'm going to do is I'll just change the colour to make it easier to see. I'm going to say C3 is, we could even write 25% of the mass of C1. Cool. So those are our two solutions. Now let's just go quickly back and have a look at what we've done, guys. First of all, in all of these scenarios, before I even started doing this video, I quickly drew up a few of the scenarios so I was able to basically visualize the problems a bit easier. And because I think the biggest issue that most people are going to face in these sort of problems is making sure that they're correctly assigned negatives to particular directions, because velocity is a vector quantity, so it does have a direction. So if these are in different directions, their velocities won't add, they will subtract from each other when we're calculating our total momentum. So this is important to make sure we make this a negative here. And drawing a picture sort of ensures that you'll, hopefully if you draw a picture, it'll sort of make that a lot easier to see or remember to do. Again, the biggest thing that we used in both of these questions, guys, was like rho 1 is equal to rho 2. That was our biggest formula. That's the conservation momentum formula. So M1V1 is equal to M2V2. And from there, in this case, we just used a little bit of algebra to solve for it. In this case here, we were just able to equate them and then move the fraction to the other side, which got us our solution. So not a very complicated question. However, it will take maybe 1 or 2 examples in your sort of study time to be able to get it perfectly right in an exam, and and you can be confident that you won't lose any marks. But again, guys, like my mantra, I say it on all my videos, is you've just got to keep practicing, practicing, practicing. If you're having trouble with these, just keep banging your head against the wall. Eventually the wall will fall down. If you have any problems with this video, please leave them in the comments section below. And again, guys, if you like the video, please subscribe, like, and thumbs up this video. It really helps people, in the future see these videos. But until next time, guys, just keep enjoying your physics, keep enjoying your study, and I'll see you soon.